All right, we are recording, and welcome back, everybody, to Paideia 301. This is, believe it or not, Class 8, and I'm hoping that you have been. I wouldn't say enjoying, but I'm hoping to say you're learning something from the class. Learning a new programming language, in my opinion, is never that enjoyable. All right, so. Um, we're gonna start with reviewing the homework, and I have three assignments I'd like to review today, very quickly, and then we are going to talk today about uh, mumps and subscripts, and then we're gonna talk about how we can use subscripts to sort, and then we're gonna discuss the do command. And the do command is one of the very big concepts in mumps, and so I expect us to cover actually spend a part of next class continuing with the do. All right, I see that Jignesh actually has joined us, so that's good. All right, so I would like to start with Tony's homework. So I'm gonna move my cursor, and I'm hoping that you could follow me with and see where my cursor is, so we could talk about what Tony did. So let's let's go ahead and start moving the cursor. It's moving. It's moving. That's good. All right. Okay. So um, let's start with this line. So this line says write hash, and that means clear the screen. Now, several of you have encountered this problem, and that is this line is gonna actually not work. We're gonna find out why in a moment. It says set if not this up caret z0 to count equal 99, and say so. He starts with the loop at 99, and then he says here, right, if $d $data, we haven't covered $data yet, of this, uh write the global out. Now you depending on the font you're using, you're gonna discover right away that he has a little problem here. What's the problem on this line? Anybody? Mm-hmm. All right. Douglas actually pointed out the problem, and Tony just pointed it out too. So he's using an O instead of a 0. All right. So I'm hoping that this will serve as a lesson to everybody that the O and the 0 are different keys on the keyboard, even though they look alike. They don't mean the same thing to the computer. So um, that's important. So we're gonna actually go ahead and fix that. So let's try another thing. I guess, and let's see how it's gonna work. Actually, no. Let's keep going. We're gonna actually run the routine. So um, there's nothing fancy about this line. It says quit is the end, and it says write goodbye. So let's run the routine and see what happens. So escape, escape. And all right. So here you go. We already start with the line that I thought we're gonna have a problem with. We indeed do have a problem with it. So let's look at it. So you see, let me move my cursor again. So you see where it says set if not z02 count upcar z02 count equal 99. So let's try that with a local variable instead of a global variable. I'm just gonna write the line. So let's pretend I have a global variable called z02, all right? So, and it's not defined like in this case. So let's write that statement. So set if not z02, that's not a global, it's now a local, z02 equal 99. All right. So essentially, that's the same error we already encountered up at the very top. That our global, we actually have a problem with our with the fact that the global is not defined or the local variable is not defined. So but you must be asking, well, surely there must be a way to write this correctly and give it the meaning that we wanted. So there is a way actually, and that way is this is an introduction to $get, and we could say set if not $get of z02 equal 99. So what does $get do? $get $get gets the value of the variable if it exists, or empty string if it does not exist. All right, so using $get, we're gonna go ahead and fix Tony's program. Now, you might be asking, okay, but how could I do the homework if you haven't taught us $get last time? Well, in my defense, I did not think everything through, but I actually expected you to set the global in advance using the terminal and or in the, as the first line of your routine, which is we'll notice that in our next in the homeworks I'm going through that this is what you have to do. So let's actually go ahead and fix Tony's routine. So give me just a moment. I need to reset my terminal. All right. And Z02 homework 7. All right. So we're gonna say set if $get of. So $get is going to return. We need to actually go out in the terminal and test this out. But for now, $get is going to return an empty string and not of an empty string. What is that? Well, we're going to find out. I will let you I will let you guess in the meantime. So just think in your head, what could it be? So, and we're gonna fix this, and we're gonna make this a 0. Nope, that's not right. Okay, this is confusing. I know it's confusing. All right. Linda's taking notes. Do you want me to just wait a moment until they're done? Oh, okay. All right. So now, but our big question is, let's print a routine. And some people have asked me, how do I look at a routine? You in GTM you use zprint. In cache use something. You also use zprint, but you have to zlink the routine before you zprint it. So if you use cache, email me offline, and I'll tell you how to do it. All right, so let's look at this line. All right, so because it's a very hard line to understand right now, and you'll need to get good at reading gobbledygook. So let's write $get of z02 count. What is that gonna be? Anybody want to guess? How did I define $get? Remember? Nope, it's not 99 because it did not run the routine yet. Remember, $get gets the variable value if it exists, or it gets you an empty string. So the answer is empty string, as Manohar said. And now Manoj. Now to verify that, I could say, write this equals an empty string. And the equality is only going to be true if it's actually equal. So far so good. Any questions on that? All right. So now what we want to do is let's do plus $get of an of this. Who wants to guess what that's gonna be? What does plus do? Ordinary plus. All right, requires a refresher. Plus converts a string into a number. Coercion, thank you. So plus of this is going to be 0. So the next thing here is, okay, so who wants to tell me what's the opposite of 0 if I put a not in front of it? That's an easy one. It's a 1. Okay, that's so far so good. So they're actually, the plus sign is actually an extra step in this expression, because plus $get is going to convert it to a number, and then the not is going to convert it to a Boolean. So what we have to remember here is we just do not $get, and it's going to convert it to Boolean right away. All right, so yes. Yes. We have somebody who has kids in the background. Can you please turn your mute, please, or mute your mic? All right, looks like that did the trick. Thank you. So, this part was really confusing. So let's actually cover it again. So MUMPS has mainly three data types. So it has numbers, strings, and booleans. Except that the booleans are really just 0 or 1. Okay, so operator causes coercion. I don't know how to spell it. Here, C-O, okay, thank you. C-I-O-N. So, for example, the greater than operator only works for numbers, and the follows operator, which we talked briefly about, works for strings. So the not and the or operator convert arguments to Boolean. All right, so um, conversion rules, and we covered this like in our I think second or third class. I'll go over it again. The conversion rules are simple, and the conversion rules are uh, convert string to number, then number to Boolean if necessary. If string if string starts with a number, it's considered numeric. So so write write 3, that's a number already, but write 33 Disney Lane, and we could put a plus sign in front of it. That converts it to numeric. Now let's convert it to Boolean. To convert it to Boolean, we just do not not. To not make a yes, and it's a 1 because it starts with a number. Okay, so we still need to go back to our, that's not good. I don't want it to type this. Oh well. Here. I'll have to figure out a way to make it type what I just want. So here we go. Here you go. We're back to our routine, and now we could try to figure it out. So if we set $get is this, and if we change it to negative $get, it's 1. So set if not $get means set if the variable doesn't exist. So let me type this down. All right. So, by the way, you are going to read this form inside of MUMPS routines millions of times, literally. You're going to see all over the code set if not some $get or $data, which we haven't discussed yet, but it's very, very close to $get. It could also means the same thing. So now let's actually try to run the routine and see. Hopefully it will actually work. All right, here you go. It actually ran. Okay, a little pause. Any questions about this? All right, moving on then. So the next routine I'm going to go over is Jignesh's routine because he had a problem and we did not have a chance to figure it out in between time for class. So let's take a look at this. So Jignesh wrote a small routine, and the question, let's actually try to figure out what the problem was. So, all right, so there are actually a couple of looks like two error messages here. It tells you that there's a label. There's a label called 1 that's referenced but not defined, and there's a label called 3 that's referenced but not defined. So let's try to figure out why that is. So let's start reading over here. So let's look at label 1 and label 3. So Jignesh, I'm impressed at the fact that you knew that labels could be numeric. I didn't think I taught in this class that labels could be numeric, but they can. So it's not giving you a compile error for that, but labels can be numeric. I did last time? Okay, good for me then. It's supposed to be a big secret because we don't want to trick people with numeric labels. All right. So, so here it says do 1. I did right, didn't I? Now I remember. Oh, bad me. Okay. So it says do 1 and then do 3. So our big question now is, where is 1 and where is 3? So 1 is supposedly over here, but in VPE lingo, it's not actually, yep, it's not actually a label. We actually need to make 1 a label. So, and 1 is supposed to go over here. So what we're gonna do is, we're going to hit enter, and before we press tab, that's really important, Jignesh, before I press tab, I'm gonna type 1 and then tab. Now 1 is a label. So, and then we can delete the 1 over here. So, the routine now is going to actually complain about 3 not being there. So let's create label 3. And look, what if I actually already pressed tab? Can I press backspace? I can't do that in VPE. So how do I deal with this situation? What I could do is I'd press escape D to delete that line and then press enter again. So escape D deletes the line. I actually need to go up and then press enter. And now I could actually type the new label. Then press tab, right, label 3, and then quit. All right. So our routine should nominally run, except we have the same problem as we had before, and we're going to find out what that is in a moment. So let's see. Okay, good. It's saved without compilation errors. Oh, here we go. It was, it exhausted its error trap, so oopsie. All right. So the error was, do we have the error? No, we don't have the error. Well, let's... All right, this is just to fix some stuff with VPE. You don't need to pay too much attention to it. Let's do this routine again. 09. Oh, well, we have a problem. Oh, here it is. Here it is. We got the error. We got the error. Here it is. Global variable undefined Z09 global 1, which is the same problem we had before, actually. So let's edit that routine, and instead of it says do 1 and then 3, which we're gonna do $get. Oh, thank you, Linda. That's a very good tip. So um, now we're gonna do $get on the global, and this way we won't crash. Go ahead and save it. Here we go again. There's an error trap that I didn't like, so I'm trying to figure out what the problem is. Write $ZT, write $ET. Well, one of them has to be a break. All right. All righty. Z go to, as Linda said, to pop the stack. Z link. Let's run it again. Okay, I still don't know what's wrong with it. No, actually, good point. I think I know what's wrong with it, but that error is actually a false error. I'll tell you why. Who wants to tell me what's wrong with this program? There's a problem that's gonna drive you nuts the rest of your life with writing mumps code. It's a very common problem. Okay, looks like it's stumping everybody. So, I'm gonna move the cursor. So we're gonna move upwards. So if you notice over here that it says do if x, etc., etc., etc. But what happens after the do? It just continues. But if you notice, the execution of one depends on a condition. Isn't that right? And therefore, it would make sense that you should not execute one for any reason unless you have met the condition already. Therefore, there should be a quit in between the do and the one label. Does that make sense? Anybody have any questions about this? Okay, I'll explain it one more time. Let's see what Alice is typing. So you're saying okay, let me read Alice's thing and Linda's thing. So you're saying that if condition was met, then the code would move to yes, absolutely. Actually, we actually have two problems. No, actually, Alice, uh, I'm not exactly sure why Jignesh likes to write complex code, but he did. He was copying me, to be fair, okay, because I was showing that to you last class. The code is complex, and it says, let's go back to the first. It's starting to highlight. No, that's not what I want. Okay. Okay, so let's. Yes, Douglas, you should be confused when numbers are used as labels. That's absolutely right. But for now we're gonna try to stick with the routine. Actually, you know what? You have a good point. You make a good point. Maybe we could just change the labels and make them more readable. So, okay, we'll do that just in a moment. But Alice, there are two conditions, and there's the read, which reads X, and then it waits for you for 3 seconds to read something. Then you have the do, and the entire do statement is conditional upon the X. Does that make sense? Okay, good. So there is another conditional, but this is different now. This conditional is an argument conditional, which means that label 1 is only going to get executed if this global has a value. Does that make sense? Okay, good. So it's like Linda's saying is like there's a G or a go to before the one in this line. Huh? Where? Sorry.
So this is like a go-to. This one, this here.
It's not a go to anymore. It's a one. It's excuse me. It's a label. So it's a do, and it invokes do runs one. Do runs one if that global is defined. So I think what confuses people is using numeric labels. So let's fix that. So here we go. Here we go. So now we have, and now we're going to change our routine to say do one if this, then three. All right. Now we are also going to put a quit here because we said we have to make the routine make sense. Okay, Jignesh actually wanted this explained again. So Jignesh, without this quit, what's going to happen is that the routine is just going to keep continue falling through because there's no quit in here and it's just going to keep going, keep going, keep going. And so it has to be, it will only stop once it hits a quit. And actually there are two quits here. There's no reason to have two quits. One is enough. Okay, good. All right, so let's save it and let's print it again. All right, so, oh, I don't know what it did, but that's not good. Oh, here we go. Okay, so this is a good note for you guys now to learn. Um, if a routine if a routine doesn't seem to be working the way you did it, you need to type ZL, which means Z-link. All right, so this is a good troubleshooting tip. If a routine doesn't work, just type ZL, and it's gonna try to compile it again. And that only works on the last routine you have in that you've edited. If you want to if you want to Z-link a specific routine, or specific routine. Here we go. All right, so um, let's see now. Let's go. Let's go print the routine again before we went on our little diversion. Okay, so let's actually run the routine. And I want we have to set the global because the global is not defined right now. So let's do that. So set this equal to 1. All right, so now z09. All right, so oh, Jignesh, it's not the same environment. That's why it's a different environment. It's not the same Paideia account. This is the V forum. Therefore, you won't have the global set. Okay, we ran the code, but the code doesn't have a lot of formatting, so we got some stuff that's a bit confusing, but we're gonna try to figure it out. So I entered the letter 3, the number 3 for x, so x became 3, and then it said do if 3 1, and so um no, hold on a moment, that does not make sense. 1 and it's gonna write the global, which oh no, it makes sense then. That's right. So I put in 3 and then it says okay, I'm gonna write 2 the global one, which is 1 plus 1, and then a new line. And the only reason it did that is because x is defined and the post conditional on the argument is true, which is $get of this. And then since x is true, the whole line is going to be run for the do, all the do arguments. So it's going to run the 3. And so here is 3, and let's look, 3 printed out. Okay. Does anybody have any questions about this? I know it's confusing, but it does make sense at the end. Okay. So good. Hopefully, Jignesh, we answered your questions, and you should be able to figure out how to use VPE. If you don't like using VPE, you're definitely free to use any editor you want. Just let me know, and I could set it for you explicitly in your initialization files. Okay. Oh, great. That's fantastic. That's great. All right. What did she tell you that helped you a lot? You could tell us. Um. Ah. A routine name should have 2 spaces. That does not sound familiar to me. I think you mean the tab. That's it? 2 spaces before the routine name. Not exactly sure what you're referring to be honest. Oh, she means the tab. Okay. Okay. That makes sense. So, okay, let's go back. Let's look at the routine again, and this is really important. So, I'm gonna move my cursor again and take a look. Let's take a look at this. So, um, in MUMPS, you have the only labels could get to start at the first line, at the first column. Excuse me. So you notice that this Z starts as starts at the first column. The 1 starts at the first column. The 3 starts at the first column. These are called labels, and they are invocable via the do and go to command, as a lot of you have done. So, when you do commands in MUMPS, there has to be a any white space, any white space. Not, but you can't type in the first line. So you have to insert either a tab or a space. It's the number of spaces or the number of tabs does not matter. It's either a tab and or a space, and it will always work. Okay. So the last routine I want to go over was uh, let's see, this is Tom Heller's routine. And Tom wrote a good routine, which is representative of the routines that have been written that work correctly. So let's take a look at Ted's routine, Tom's routine, excuse me. So Tom created a twist on the program. It's now about your age rather than at just a count. And what you he said, he reads the age, so that's the line that my cursor is on right now. Then he writes the menu, and then he reads what I want to do in the menu, and then he adds or subtracts depending on this, and then he does a go to, and the go to just prints a message and goes back essentially. So let's actually give it a try. So it's a very simple routine, not that hard, but I wanna turn your attention to see. We've been talking about post conditionals a lot, and he actually has three of them in a row. So he says go to if m2 equals 1, go to if m2 equal 2, go to if m2 equal 3. So let's actually run it. Oh, good. All right. My age. Well, I'm going to be 16. Add 1. I'm 17. 18. 19. I'm 18. I'm 17. Oh, it really works really well. I like it. And then 3 to quit and gives you your last age, and we're done. So it's a very nice program, very simple and straight to the point. Now, one last thing I actually want to talk about quickly is um, in the homework assignment, I asked you guys to make your global in your namespace. Um, a lot of you have not done that. And so Tom, for example, has a global called age. So um, it's fine if you're playing around in a Paideia environment, but this is one good lesson for you guys to remember. Um, in Vista, one of the big sins that you could ever make, one of the biggest sins you could ever make, is use a global outside of your namespace, because somebody else could be using that global, and namespaces are pretty partitioned. You can usually, in a production environment or a testing environment where you're running Vista, you can usually get away with using anything in the ZZ namespace. That's always available, and you could always use ZZ for yourself. Yes, exactly, Ted. That would be Z0. For Tom, it would be Z08 age rather than upcaret age itself. Okay, so that's pretty much our coverage of our homework. And oh my God, we spent 45 minutes on it. Okay, So Linda's sending you more tips on editing, and while she's doing that, I want to start talking today about uh, mumps sparse arrays, or we're just gonna call them arrays, and we're gonna talk about subscripts. Um, Now, let's before you look at the diagrams that I sent you today, which are attached to the email. Let's just start off with explaining what we're gonna talk about. So far we've been dealing with variables like x equal 3, and so if we set x equal 3, we write x, and if we zewrite x, you get x equal 3. Zewrite, by the way, we're gonna use it more today. I'll show you what's it useful for. Um, where these kind of values are known in programming as scalar values. So that's a strange word. Let's spell it. Scalar values. So scalar values means that a variable has only one value. Scalar values are not the only way you could store variables. In fact, in MUMPS, it's far more common to use the other kind of variable uh, in a other kind of values inside of a variable, and we're gonna call these, for now, array values, and means that a variable can have multiple values. So, um, more, I'm trying to how to word this. Most other programming languages, when you say array, they usually mean a C array, and a C array essentially is a memory data structure that points to memory, and it points to the specific bytes in memory that you have stored. In MUMPS, an array is not the same as as the C array. It's a totally different thing, but what's common in between the C array and the mumps array is that they can store multiple values. So for example, we can say set x equal 5. Could say set x sub. All right, you remember I said sub. This is important. Sub 1 equal 3. Set x sub 2 equal 8. Set x sub 8, oh no, sub 5 equal 2. Now, I'm going to write x, and I'm gonna show you, instead of the zwrite command, and zwrite x. Now, write actually gives you the value you're requesting at that specific time, which is just x, or you could actually write x sub 1 or x sub 2. Zwrite just prints you an array, prints you the variable and any array elements that variable has. So um, you you're looking at this, and it's now looking okay. I think it looks good. It somewhat looks like a C array, but here we go. It's not exactly like a C array, because you can also do this. Set x index. So this is not something you can do, because this is not something that's stored in memory as just a straight array. This is pretty different. No, it's 1. It's 3 and it's 1. So let's look at x again now. So you could see now that we have something a bit different here. And x, we have x sub 1 defined, x sub 2 defined, x sub 5 defined. We don't have 3 and 4, which is actually somewhat unusual. Not your typical, not what you expect typically from a lot of the languages that you might have learned before. It's a bit different. And you have we have something called index, and I called it index because guess what? This is how you index data in FileMan and in MUMPS. Is you basically you index the values and you tell the computer, okay, that value is found in this position. So that's essentially a mini array and almost a mini FileMan file. So the thing about this to understand is that uh, this is how mumps works. It does not, when you store the data points 1, 2, and 5, mumps does not store anything in 3 and 4. So that's so important. I'm gonna write it. So um the other thing that's pretty unique about arrays is that you notice that let me move my cursor. You notice that the first part of the array has a single subscript, and the next part of the array has two subscripts. So if you've done basic, you will remember that this is they used to call them dimensions in basic. So you could say that this array has one dimension and this array has two dimensions. So essentially, what MUMPS has is multi-dimensional arrays by default. So let's wrap this up. So we have you could store something. You could store something, and if you store something, you could store them far apart, and MUMPS doesn't care. It doesn't populate the middle, and it's multidimensional. So and and guess what? The array data structure is how you store data in MUMPS because you don't stay. Oh, good question, Alice. I'll get back to that. Yeah, globals and mumps are look exactly like this, and this is how you store your globals on disk. So let's wrap this up. I know I'm pausing too much, but let's wrap this up. It's the mumps storage is called, if anybody asks you, sparse multi-dimensional arrays. Sparse means that any pieces in the middle don't get populated. So, like we said, if we store something in 1 and 2 and 5, we're not storing anything in 3 and 4. That's what sparse means. Okay, let me try to answer Alice's question. X equals 1, 2, 3, and 4. This looks to me like I'm trying to remember what language that looks like. I'm not exactly sure. It looks basic-ish and C-ish. It doesn't work since you're not specifying. Uh, that's correct, Alice. X1 is a node, and mumps does not have the same arrays as C because uh, if you have the C array, if you said x equals 1, comma 2, comma 3, comma 4 in C, and you defined X to be a character data type in C, then what's it gonna store it in memory is it's gonna store 1 in the first byte, 2 in the second byte, 3 in the third byte, 4 in the fourth byte. And if you don't specify something, it's gonna skip it and it's gonna keep its place though. That's why it's not sparse, and store the 4. Um, in contrast, when you set an array in mumps, internally it's usually implemented as a C data structure called a linked list, which you don't have to know. So basically, each node lives in its own space and has links upwards and downwards to the next nodes. And that's why it doesn't need to know, it doesn't really need to know about the middle nodes. Does that make sense, or have I over explained it? Okay, good. I have a feeling I over explained it. You don't really need to know how it's stored in the C language. That's not not what we're here to talk about. All right, Jignesh is typing a question. I'll wait for him. Uh they are kind of a linked list, but it's not how they're presented to the user. They are implemented in the C language as a linked list. So basically, a linked list has pointers to the previous item and the next item, and that's how mumps essentially. That's how an array is actually implemented in C. But when we start looking at it in more detail, we're gonna get an idea. So let me do this. I need to sprint. Just a moment. I just need to print something from my system. That's not too much. Ah. Every time I type ZeroIte, it prints 1,000, 2,000 lines. I'm not faster than the computer. Let me try. Okay. I want to paste something, but if I paste something here, it's gonna crowd all over the screen. So let's see what I could do to paste something. So here I have an idea. We can type cat. All right. So I have it. I have it there twice. Well, that's okay. All right. So um, this is sorry. Okay, don't. I wanted to delete stuff, but I can't. So this, what you're looking at, is a typical array in mumps. This is a fileman file, and let's see if if I could move my cursor. Yes, I can. All right. So let's start looking at everything here. So I started with 56, by the way, and I told it to print. I told GTM to start printing out from PS56. And I want you to notice there's no such thing as PS56 by itself. It's only PS56, 0. So that's the first node, and that usually indicates the file header. Then each entry is on a different node, and you have entry 1 is on 1, entry 2 is on 2, and so on. And what does this file represent? It's the drug interaction file, which Vista used to use before they replaced it with first data bank interactions. That was up to 2000 and I want to say 2011. So this is a typical global data structure. So now we've taken a look at that. Let me press escape and get out of this. I want you to open the diagrams I sent you via email. The email was titled Diagrams for Today's Class. And I want you to look at MUMPS Global 1 .png, and they're actually very similar files, so you could either one would really work. And this diagram is important. Again, my deepest thanks to Douglas for making this diagram, but it gives you an idea of what arrays and mumps look like. They don't really look like arrays. They look more like trees. They don't look like arrays. They look like trees. And there are important characteristics of trees, mumps trees. One thing is that not every branch has a value. A branch could just exist and have descendant branches, but it doesn't necessarily contain a value. So, let me see. So, if you look at the diagram, the PS does not have any value. And it's not in the diagram because it did not have Douglas draw it, but PS56 by itself does not have a value either. But PS56.0 has a value. So one question we usually ask moms, and I'll tell you how to do it in maybe next class, and we usually ask moms, does this global node 1 exist, and 2, does it have any descendants? And mumps gives you different values on whether it exists or not. So whether it exists and whether it has descendants. So all right, let's take a look at 56.0 itself. Does 56.0 have any descendants? Yes or no? Question for the class. All right. Ted thinks that it does. Alice thinks not. Okay. So actually, the answer is no because there is nothing under the 0. So if you saw a node called 56.0, 0, then 1, then you'd have a descendant node. Okay, let's talk about 56.1. Forget about the other subscript, just 56.1. Does 1 have any descendants? Okay, that's 1 does have descendants. What are 1's descendants? If you look at that diagram. Yeah, that's exactly Menage. That's correct. All right, Ted gave me 5611. I'm trying to remember where. I want to see where he got that one from. That's 5611. Okay, that's not a descendant. That's actually the entire node. It's 56 comma 1 comma 1. But when I ask if the 1 has descendants, it means that the 1 node which is a branch in a tree and it has 0, 1, and ID. Okay. The following ones are going to be easy. Does 56B have any? Does it have any value? It's right on the diagram, right? Does B8 have any value? Again, right in the diagram. But notice that both B and B8 both have descendants, and the last descendant is the 1. Excuse me. All right. So, speaking of descendants, let's go. I'm gonna head back to the terminal now. I see Manoj is asking a question. I'll wait for him. So does it mean that 8 has a descendant? 8, yes, has a descendant. That the descendant of 8 is 1. Okay, good. All right. Um so let's start with a simple case, and we're gonna start going up from there. So, um, actually, before I was thinking that I'm gonna teach you the about dollar data and dollar order right now, but before I do that, I need to remember to teach you about sorting in MUMPS, or the fact that you never sort. So, let's talk about sorting in MUMPS. So set x sub 3 equal a, set x sub 1 equal b, and set x sub 8 equal q. All right, so let's zero-write x. Okay, I want you to notice something important here. Even though I entered the names of the numbers in 3, then 1, then 8, when MUMPS stores the data and gives it back to you, it always comes back in the order of the subscripts. So this is important. Now, of course, you might be saying, oh, boo-hoo, big deal. Doesn't doesn't matter here. Yeah, sure, it's just a number. So you're right. So subscripts in MUMPS auto sort. That's very important. So very, very important. So so this case is not practical. Let's get a practical case. So I'm gonna go through my class roster and I'm gonna type your guys' names. What did I do wrong now? Set x equals x sub. I don't see anything wrong. I must have mistyped something, so I'm gonna start over again. Double quote, I missed the last quote. Oh, I did miss the last quote. Thank you. Good job, guys. Students are becoming the masters. And the next one I have is Linda. Oh, it's called me being dyslexic now. Here we go. All right, so who thinks will show up first? Okay, good. And who's gonna show up last? All right, Linda raises her hand. So let's look. That's exactly right. Tony shows up first and Linda shows up last because Linda's last name begins with Y. So this is a very important property of mumps that it's very important, and I'll tell you why in a moment. But it's why am I saying this? Never mind. um, so let's look at a FileMan B index. Now, what's a B index in FileMan? Well, whenever you create a file in FileMan, the very first thing that FileMan does when you create the file is that it creates a B index for you. Let's see what's stored in the B index of the new person file. All right. We saw that there's a lot that scrolled through here. But the B index is what FileMan uses to query the MUMPS database in alphabetical order for your files. Now, whenever you do an inquiry in FileMan, guess what does FileMan do? FileMan just the first thing it does is that it looks at the B index and gets you the entries in the order that you specify them. You excuse me, in the order that MUMPS has them stored in the B index, sorted by the name. And if you don't want to use the B index, there is stuff called the C index and so on, and you could use these as well. The C index, I'll give you another index that I know in the in file 200, and that's the social security number index. And you could see, if this was a real system, you'd be able to see everybody's social security numbers. And those social security numbers are sorted, actually, I don't want to confuse you guys, but they're sorted alphabetically, not numerically. I don't want to confuse you, but take it at my word right now, because that's we're gonna have to explain this later. Somebody had a question. Was it you, Linda? No. Okay. Sorry. Okay. All right. So here's let's take a look at let's take a look at this last node down here. So let's just say write this. Now it's time for us to try. It's time for us to learn about dollar data. All right. So you have dollar data of 10. Now that's that. Well, we're gonna figure out what that means. We're actually gonna guess what it means. Do I have this right? Yes, I do. Okay, that's good. So this is good, but there's also another type of thing which I can't illustrate here. But let's start with the 10 and the 1. So if a node dollar data is the way to test if a node has descendants or not. So, and if it has value. So the value of 1 Oh, let me write the rest. Is a way also tests whether a node has a value. So using this logic, so let's see how we're gonna think about this. So you have 10 and 1, and I'm gonna make an example array that's easier to test than this one, so I could show you all cases. So set x sub 1 equal node 1. Set x sub 1 comma 1 equal node 2. Set x comma 2 comma 1 equal node 3. All right. So I think I'm going to show you dollar data with this one, so it might be easier to understand. So if I write dollar data of x sub 1, it's going to be 11. And then I'm going to do write dollar data of x sub 2, and that's going to be 10. And we're going to write dollar data of x sub 2 comma 1. That's going to be 1. We'll write dollar data of x sub 3. And that's 0. Huh?
Oh, you said it earlier.
I said it earlier. Okay, sorry guys. Pretend that x sub 3 does not exist, okay? So x sub 3 does not exist anymore. All right. And then x sub 3 will be 0. So dollar data essentially has 4 values. Dollar data of dollar data of a non-existent node is a 0. Dollar data of a node that has a value like x comma 2 comma 1 is 1. Dollar data of a node that has no value but has descendants as an x sub 2 is 10. And dollar data of a node that has a value and also descendants as an x sub 1 is 11. So I know it's a bit confusing right now, but eventually you get used to it. Now, inside of Vista code, you often see the following a lot, and what you see is if you see if dollar data of x sub 2 divisible by 2. Sorry, I need to do this. Okay. So we have to think about whether excuse me, it's divisible, but the word is modulus. Excuse me. If it's modulus 2. So the modulus 2 actually tells you does your node have a remainder if you divide it by 2. And the only nodes that have remainders when divided by 2 is if it has a value, which is this case. Let me move my cursor. This case and this case. They're both divisible. They're both going to leave a modulus when you modulus them with 2. So So you sometimes see this. If dollar data of x sub 2 is divisible by 10. Now, if it's divisible by 10, it means that 10 will not give you any value, but 11 will give you a value for the modulus. And so and here's my favorite one, which is used. It's used uh, in the cases that I've seen it used. It's been only used by fileman. If dollar data of x contains 0. So you might see these things in code. You will not get to use them yet, but hopefully you will eventually get to use them. Um, and I'm trying to think what else we need to cover for today's class. Well, I think I'm actually gonna stop here for today, and next time I'm gonna try to cover dollar order to help you traverse arrays. So I think that's it for today's class. And sorry guys for my on and off halting speech. So hopefully I'll feel better next time. All right, that's it for today. And no homework assignment if you haven't done it yet. Remember, we had 2 homework assignments last time. I one to read the one to read a routine and comment out which stuff is routines and which stuff is globals. Which up carrots are routine and which up carrots refer to globals. And your other assignment is to write a routine that increments or decrements a global using a menu system. All right, that's it. Any questions? Yes, Alice. By the menu system, is somebody has to choose a list of options. I'll try to make sure to resend the homework assignment again and make sure that make sure you could do it too. All right, that's it, folks, and that's it.